Hi, I'm Colin Walls, and I'm here as usual to talk about embedded software. Today I want to consider a particular feature of real-time operating systems. This is a feature which people often ask me about, and I thought it might be worthwhile putting together a bit of an explanation. Now, when you use a real-time operating system, you communicate with it from your software via the API, the Application Program Interface. Now, the API consists of a number of calls to services provided by the operating system. Those services are quite variable, but many of them involve gaining access to some kind of resource. You might be trying to communicate with another task, you might be trying to access a device, all kinds of resources. You might be trying to grab some more memory, for example. These resources are in limited supply, ultimately. There's very rarely would you have a resource where there is an infinite quantity of it. So whatever you want may or may not be available at the time you make the API call. How is that managed is the question. Now, the way it's managed in most real-time operating systems is to offer what we call blocking, and unblocking API calls. Now, a non-blocking API call is one where the call is made. If the resource is available, that's fine, everything progresses as planned. And if the resource is not available, you get some kind of error response. Now, if you get that error response, what would you do? You would probably go to sleep for a while and then have another go at getting the resource. The blocking API calls are much more convenient because what they do is they attempt to give you the resource, but if it fails, the task is put to sleep until the resource is available. That's much more efficient because the task doesn't waste CPU time by waking up and still finding the resource is unavailable. So it really efficiently matches supply and demand of resources. This is okay unless, for example, multiple tasks want the same resource. How is that managed? Well, in that case, it depends on the operating system, but multiple tasks can be blocked on a particular resource, and which order they're woken up in is controlled by the operating system. Let's take a little look at an example. If you take Semaphores. Now, Semaphores are supported by the Nucleus RTOS, and you might make a call like this in order to create a semaphore. The last of the parameters on this call, we don't need to worry about all the details at this point, but the last parameter is the one that determines how the task is suspended if it's blocked. And this determines how the tasks are woken up after the blocking. And we can set suspend type to be NU priority, which means tasks are woken up in priority order. So a high priority task will get the resource first, which is usually the way of operating. Alternatively, you can use NU FIFO, and that means that the tasks receive the resource in the order that they requested it. So first in, first out. So that's quite straightforward. Now, if you want to obtain a semaphore in Nucleus, you make a call like this. And again, the call has a parameter associated with suspending, and that's the last parameter there. And you can set this to one of three possible types of value. You can set it to NU suspend, and this simply means that you want to make a blocking call and just hang about waiting for the resource to be put to sleep. You can use the value NU no suspend, and this simply means you'll make the call, and if the resource is not available, if the semaphore's not available at this point, just return immediately with an error message. Or lastly, you can put a value in there, which is an integer value of the number of ticks that you want the clock to have taken before it returns. In other words, you can have a timeout. So that it means the task is suspended, but not suspended indefinitely. That's a lot of flexibility when it comes to handling blocking and unblocking calls, and that's typical of Nucleus. Most of the calls take the same kind of form. It's very orthogonal in its structure, and the use of blocking and non-blocking is right across the board, almost every kind of resource you can imagine. So that's a very brief introduction to a feature of real-time operating systems that some people find a bit confusing. I hope you find that helpful. If you're interested in real-time operating systems generally, there's lots of resources available, like my blog and so forth, but I'm just about to start a new series of articles on embedded.com called RTOS Revealed. This is a series of articles which will go on for the rest of this year, way into next year and beyond, looking at all aspects of real-time operating systems. If you're interested, pop over to embedded.com and you'll find the introductory article is there now, and others will be following in the weeks and months to come. So do take a look and let me know what you think. For today, that's the lot. Speak to you again soon. Bye for now.